Okay, this is solution to problem number 2. Our equation is -3 plus 3 cosine x equals sine squared of x. And remember that with our Pythagorean identities, we might be able to change sine squared into something in terms of cosine, so the whole equation would be in cosine. So let's take a look. Our Pythagorean theorem is sine squared plus cosine squared equals 1. And if we were to subtract cosine squared from both sides, these would cancel and we'd be left with sine squared equals 1 minus cosine squared. So we can sub that expression in right here for sine squared. So we have -3 plus 3 cosine x equals 1 minus cosine squared x. And now we just want to get everything on the other side of the equal sign. So we'll move the cosine over, make it positive cosine squared plus 3 cosine minus 4 equals 0. So I added this cosine squared over to get to this. This is my 3 cosine squared that was always here. And when I subtract the 1 from the -3, that gives me -4. And now it's equal to 0 and it's ready to be factored. So factors of -4 that combine to give me 3 would be 4 minus 1. So cosine x plus 4, cosine x minus 1. So we set each of them equal to 0. And we get the cosine of x is equal to 4, and the cosine of x is equal to 1. So now we remember from the unit circle that the largest possible cosine value is 1. And so the cosine equaling 4 will not give us a solution. There's no solution from that factor. But cosine can equal 1, and it does so at 0. If you think of the unit circle, cosine is 1 right here at 0. And it asked us for the general solution, so 0 plus 2 pi n would be the solution and the only solutions to this equation.